one decorator, and one ACP clean IO, and that's all you need for your agent to slot seamlessly into an ecosystem of AI teammates, with no vendor lock-in. Some of ACP's core strengths are simplicity and flexibility, meaning you don't need to change how you build agents. ACP is framework agnostic, so you can use any stack or toolchain to build each agent, but agents using completely different implementations can still work together as a team with no vendor lock-in or forced migration. Here's a quick example of how easy it is for you to wrap an agent using the ACP SDK. If you've already built a super cool and more complex agent that you want to make ACP compatible, then swap the agent that we're going to build today for yours. Ensure its inputs and outputs are ACP compatible, and you're good to go. For sake of simplicity, we're going to implement a simple agent using LangChain that is enabled with memory. First, import the usual libraries like typing, OS, and .env to grab our secrets. Then we pull in the ACP SDK primitives like message part, and server, plus a couple other helpers for streaming. Finally, we grab any required libraries for the agent itself. In this case, we're using LangChain and LangGraph. We load our Anthropic API key from the .env file. We create a state for the agent that keeps track of message history, and with a LangGraph helper that automatically adds new messages as memory. One line, and our LLM is ready. We're using Claude, but you can use any provider your framework of choice supports. Then you create the server, which exposes HTTP endpoints for every single agent that you register. By default, it listens on port 8000, which is perfect for local development or a lightweight container. Next, you wrap your agent function with the @server.agent decorator. This decorator is the only ACP-specific line that you need. Whatever comes next depends on your agent implementation. In this case, we flatten the incoming ACP message objects into a single prompt to be compatible with LangChain's expected input. We then call the LLM and package the response back into an ACP format so it can be used with other ACP agents. Then we run the server to spin up an ASGI web server and mount every function that you decorated with the @server as a runnable agent endpoint. Once the call returns, the process is listening on the HTTP port, and your agent is reachable by any ACP-compatible client. Now you can talk to your agent with a curl, or you could also configure a client that calls the ACP server. For sake of simplicity, we'll just test our agent using a curl command. Once we have the server up and running, I send the curl command prompting the agent with "Tell me about agent communication protocol." That's it. One decorator, one curl command, and you've got an LLM agent with conversational memory exposed over HTTP.